What determines whether an object will float or sink in a liquid? By doing an observation, okay, we can see that some objects sink in water like rocks and metals, while others can float on top of water or the liquid like ice and plastic. The reason behind that is called the density of the object. Okay, the density is actually how much the mass is being distributed on a specific volume. Okay, and so it's equal to mass divided by the volume. And since the mass has a unit of kilogram and the volume has a unit of meter cubed, hence the density will be in kilogram per meter cubed. And this is the triangle linking density, mass, and volume. While you need to know that the density is represented by the Greek letter, it's called rho. Okay, that's the Greek letter, it's rho. Okay, now let's take an example in order to understand furthermore. Let's take two identical sized cubes, one that is made out of iron and the other is made out of wood. By doing a simple observation, we can know that the iron will sink, the wood will float. Okay, now if we take both mass and volume of each of them, as we said, we have the same volume, so they are the same sizes, hence the same volume. But if I put the iron on a balance, it will be much larger than the wood. Okay, so applying the rule, the formula, density is mass divided by volume. Okay, so by applying the formula, density is mass over volume, we can get the density of iron and the density of the wood. Now we can clearly see that the density of the iron is greater, much greater than the density of the wood. But will this be enough to say that iron will sink and wood will float? No, it's not enough, because we need to compare the density to a specific number. In fact, what we're comparing is the density to the liquid it is placed in. And so the density of the water is known to be 1000 kilogram per meter cubed. That's the density of water. Okay? Since the density of iron, which is 8000 kilogram per meter cubed, is greater than the density of water, hence the object iron will sink in water. While since the density of the wood is less than the density of the water, this is why wood will float on top of the water. Okay, now the frequently asked question usually is, okay, does the density of water change? In fact, the density is like one property that is fixed for each element. It doesn't change not only for water, but also for all the elements in the periodic table and all the elements that are around us. The density is always a fixed property. Okay, now how does knowing the density of an object help? Since elements have a fixed density, then we can identify any anonymous element by only calculating the density. By calculating the density of an anonymous object, and then we compare this to a result data that is also, it will be given to you. Okay, and this is one simple table. That's a simplified table showing how density of different objects change. Okay, and you see that the air has a 1.3 kilogram meter per meter cubed as the density. Okay, so these are some direct application. You can also pause the video and do them by simply applying the rule. Okay, and you need to not forget how to get the volume of regular objects, because sometimes volume won't be given to you directly. You'll have to calculate it. You'll have to do the calculation. You will mostly need the cube, rectangle, and the sphere. Okay, now the thing is that not all objects have regular shape to calculate their volume. Then we must find another way to find the volume, and that would be a criterion based on IV. In case we have to in such case we have to do an investigation. we will take material balance, a measuring cylinder, and the object that we want to define the volume, and some water. First, you make sure to tear the balance. Tearing the balance means that you need to make sure it's 0, okay, at scale 0. Place the rock carefully on top. Once it's settled down, record the mass in grams. Take the measuring cylinder, pour 30 milliliter carefully. Place the rock in the cylinder. Then, by having your eyes leveled to the measuring cylinder, record the new reading of the water in milliliter, and then you calculate the difference between this measurement and this one, and you'll get the volume of the object, because the volume of the object will actually displace the water above it. And then by applying the rule, the formula density is mass over volume, you'll then get the density of the rock. And that's one example. So that's my my balance. I place the rock, I have the mass, okay, so that's the mass. I will record it, it's 25 grams. And then this is my original, and that's the last one. So you'll do 40 minus 30, that's 10 centimeter cubes mean milliliter. So now I have a volume of 10 milliliter or centimeter cubed. Next, you're gonna do density is mass divided by the volume. You'll do 25 over 10, or you can convert. I'm just gonna keep them for now to be 2.5 gram per centimeter cubed. Now you take this number and you compare it to the data table that was mentioned in the previous page, and then you can know the element, and this rock is made out of what exactly. Okay, so you're responsible of this criteria and this trend. Okay, now how can this be so useful? In fact, geologists use this method in order to measure the density of rocks, and then this helps them to identify what kind of rock they are dealing with. Okay, and also milk inspectors, they measure the density of the milk to see if it has been watered down. Okay, because some company they pour, or like they water the milk down, and so the inspector will have specific tools to measure the density. As we said, density is something fixed, it's a fixed property, so this helps them in order to identify whether the company has watered the milk down or no. Okay, so now in order to understand more how density works, I'm going to take both blocks, iron and wood, which we already know their densities by doing the calculation, and we'll try to submerge both of them, first time in water and then in mercury. So if we take the iron block and we submerge it in water, since we know that the density of iron is greater than the density of water, so iron will sink in water. While if we took the wood block, since it has a smaller density than water, so wood will be able to float on top of water. As for mercury, if we submerge the iron in mercury in a bath filled with mercury at room temperature, then we can see how, since iron has a density that is smaller than the density of mercury, where we already took the density of mercury from a table chart or data table, since it's fixed, doesn't change, so iron will float in mercury, same way that the wood will also float on top of mercury, since it has a density smaller than the density of the liquid submerged in it. So this shows that in order to decide whether an object will sink or float, we should always compare the density of the object with the density of the liquid that we're submerging the object in. Okay.